All right, geometry 3-5, proving lines parallel. Part of this I'm going to write, and part of it I'm just going to show you, and you can copy at your own pace. So we're going to start with 2 lines and a transversal, and then we've got all of these angles here written out or named, labeled, and we've got these 2 lines A and B here. And so we can use a transversal and the angles that are created to prove lines parallel. So this first section here is the converse of corresponding angles postulate. Blah, blah, blah. All right, so if 2 lines are cut by a transversal, there's a transversal, so that corresponding angles are congruent, say angle 1 and angle 2, those are corresponding angles. If they are congruent, then the lines are parallel. So the reason this is the converse of a corresponding angles postulate, remember we talked about the corresponding angles postulate a couple lessons ago. The corresponding angles postulate said if the lines are cut by a transversal, then the corresponding angles are congruent. This is saying if the angles are congruent, then it is a parallel, then they are parallel. All right, so if angle 1 and angle 3 are congruent, angle 2 and angle 4 are congruent, we're just listing all of these corresponding angles, then A is parallel to B. Here's the parallel postulate. If a given line and a point not on the line, there is one line through that point that is parallel to the given line. All right, let's read that again. Let's see if I wrote this right. If given a line and a point not on the line, there we go, there is one line through that point that is parallel to the given line. Okay, so what that's just saying is if I have a line and some random point out anywhere, I could draw a line through that point and it can be parallel to the original line. That's all that this is saying. Then we have these converse theorems that prove lines parallel. So we didn't write out all of them. We just wrote the names of each one. So we've got, what this is referring to is a couple lessons ago when we said the alternate exterior angles means if the lines are parallel, then the alternate exterior angles are congruent, and we're just saying that the other way is true as well. The converse is true, such that if the alternate exterior angles are congruent, then the lines are parallel. So we're just kind of saying the opposite thing. And so these are all consecutive interior angles, converse, alternate interior angles, converse, perpendicular, transversal, converse is if 2 lines are perpendicular to the same line, then they are parallel. Okay, so you can pause or whatever and catch up. And then we're going to go ahead and I'm going to start writing the rest of this example here. So which lines are parallel? And which theorem or postulate is used? So we're going to draw 3 lines that look like they're all parallel to one another. And we're going to draw a transversal that goes through all 3 of those lines. And the transversal is P, this top line is L, the middle one is M, and the one on the bottom is N. This angle here, right below P, where we wrote P, is angle 1. Then the vertical angle to angle 1 is 2. And then down here is 3. below 3 is 4, and then we've got, keep going down on that side of the transversal is 5, and then we've got 6 as the vertical angle to angle 5. All right, so we're going to have 3 of these different exercises here. So angle 1 is congruent to angle 6. So which two lines are going to be parallel, and which theorem do we use here? So angle 1 and angle 6. I've got angle 1 right here and angle 6 down here. So these both are using the transversal as part of the angle. And then we've got line L and line N. Line M is not involved with these two angles at all. So 1 and 6 are alternate exterior angles if we're talking about these two, L and N. So these are alternate exterior angles. And this is the converse of alternate exterior angles. Since these are congruent, then these two lines, line L is parallel to line N. Let's look at another one. Angle 2 is congruent to angle 3. So here's angle 2, and here's angle 3. So we're talking about line L and line M now. And angle 2 and angle 3 are interior angles, and they are not on the same side of the transversal, so they are alternate interior angles. And if those are congruent, then we know that the converse of the alternate interior angles theorem is what we're going to use here to say that L is parallel to M. All right, now we've got angle 2 is congruent to angle 6. Now, go ahead and see if you can figure that one out on your own. Go ahead and pause and we'll be right back. All right, let's see how you did. Angle 2 and angle 6. So line M is not involved in angle 2 and angle 6. And so we've got line L and line N again. This time, angle 2 and angle 6, see how they are both on the lower right of the intersection? So those are corresponding angles. So I know my theorem is the converse of corresponding angles theorem, and so L is parallel to N. All right, let's do another example. Let's see what we got going on next. Find measure of angle MRQ so that line A is congruent or parallel to line B. All right, so let's draw the diagram here. I've got two lines that look like they're parallel to one another, and I've got another line that goes through there, and that is called the transversal, which is C. Line A is this one here on the left, line B is this one on the right, and then I've got a point here that is L, R, and then M, and then on line B I've got N and P, and then over here on the right of line C is point Q, and I believe that's all of the points. There we go. And here, this angle is 5x plus 7 degrees, and this angle here is 7x minus 21 degrees. So I need to find MRQ, that's this angle right here, so that angle A, line A and line B are parallel. So I need to look at these two angles and I think, okay, these are alternate because they're on the other opposite side of the transversal, and they are interior angles. So I know that alternate interior angles are congruent, so I can put these two angles equal to one another. The measures are equal. Because I got to solve for x so that I can figure out what this angle is. So if I set these two equal to one another, then I know that I can find out what x is going to be. So I'm going to subtract 5x from each side. And since we're in geometry, I can do kind of two steps at one time. So the 5x's go away, the 21 goes away, and now I've got 21 plus 7, which is 28, equals 2x, divide both sides by 2, x equals 14. Now, I'm not done yet. My question is, what is the measure of MRQ? So that means I still need to plug this 14 back into the original equation. 5 times 14 plus 7. And so 5 times 14 plus 7. So 5 times 14 is 70, plus 7 is 77. So measure of angle MRQ is 77 degrees. Let's do another example. So we're going to draw the diagram first. Let's draw two lines that look like they are parallel to one another. Let's draw another line straight down like that. We put a little box in there. This transversal is line D, and then the top line is E, and the bottom is F. And we're asked to find Y so that E is parallel to F. Now, y, you don't know what it is yet because I haven't given it to you. 4y plus 10 degrees is the measure of this angle right here. Okay, so I've got to think about, okay, what do I know about this? This is 90 degrees, and if I'm going to prove that these are parallel, I'm going to say that this needs to be 90 degrees as well, because if these are parallel, then all of the angles are going to be 90 degrees if just one of them is 90 degrees. So all of these angles need to be 90 degrees. Therefore, I'm just going to take this angle and set it equal to 90 degrees, and I'm going to solve for y. For y equals 80, divide by 4, y equals 20. And that is what they asked for. Just find the value of y, and there it is. Okay, let's do a proof here. Let's see how this goes. All right. Yay, proofs. Given angle 1 is congruent to angle 3, and segment AC is parallel to segment BD. And we're going to be asked to prove that segment AB is parallel to segment CD. All right, let's draw this. So I'm going to start with a ray like this, and then I'm going to draw two line segments like this, and then I'm going to draw a ray off that direction. Okay, this is A, to the right is B, below B is D, and to the left is C. Now this angle A here is angle 1, this angle at C is 2, and this angle to the right of point D is angle 3. So we are told that angle 1 is congruent to angle 3. So let's draw that. And then we are also told that AC and BD are parallel. So that's AC here is parallel to BD here. And we are being told to prove that AB is parallel to CD. All right, statements and reasons. So I'm going to start with angle 1 is congruent to angle 3, that's given. And also AC is parallel to BD. So those are my given information. And so I am going to say now that angle 2 is congruent to angle 3. Because what I'm trying to do here is I'm trying to prove that AB is parallel to CD. And I know that these two are congruent. Now, if these two lines are parallel, then I have this transversal here, and I also have this as a transversal right here going through these two lines. So that means that these two angles here are corresponding angles. And angle 2 and angle 3 are congruent because they are corresponding angles. These are parallel. Here's the transversal. This is a situation where we have two transversals. And so these two are congruent. So this is corresponding angles are congruent. Now that I have these two corresponding angles congruent, I can start thinking about a way I can say that these two are congruent, and these happen to be alternate interior angles, and so if they are congruent, then I can say that these two lines are congruent because this transversal cuts it so that the alternate interior angles are congruent. So I'm going to say now that angle 1 is congruent to angle 2, and that is the transitive property. That's the one that says if 1 is equal to 3 and 3 is equal to 2, then that means 1 and 2 are also equal. So that's a transitive property. And now, since angle 2, since those are congruent, angle 1 and angle 2, then that means that AB and CD are parallel because of the converse of the alternate interior angles theorem. And that is the end of 3-5.